This is day 5 of chapter 2, Probability and Statistics. Our topic today is misleading graphs. So our essential outcome is that you'll be able to talk about and describe misleading graphs. So remember, we've talked about all these different graphs. So far we've talked about histograms, we've talked about bar graphs, we've talked about stem and leaf plots, we've talked about dot plots or dot graphs. We've talked about circle graphs. One we haven't talked much yet about is this one down here. This is a box and whisker plot, which we'll talk a little bit more about later on. So when graphing, a lot of times it's easy to manipulate the graph to kind of serve what you want and to make it appear to display something that may not be actually all that accurate. And so we're going to talk about some of the different things you need to pay attention to when you're looking at graphs so that you don't fall prey to these types of things. And so here we have this graph right here, and it says massive increase in home price. So obviously the person's trying to get across that home prices have increased a lot from 1998 to 1999. And so we're finding the average house price in euros. And so if we look at this, in 1998, it looks like it was $80,000. Okay, so 80,000. And in 1999, it looks like it's grown a lot. But what it's really saying is that it's 82,000. And so it looks like there's this massive increase in housing prices, but it's really only a $2,000 increase from year to year. And so they were able to kind of mislead you with this graph by zooming in on it. And so if you notice that our y-axis down here, it starts at 79,000 instead of starting at 0. Now if this graph started at 0, this gap in between our two bars would look drastically different. And so this is one technique that is used quite often. And so here we have another one where annual snowfall in 2001 and 2002. Here is the first graph they give us, and we see that it goes from 16 inches to 24 inches. So that's, that's a little bit of an increase, but not all that much. But if we look at this other graph over here, there's a really big gap. There's a really big increase between these two. Now, these are actually representing the exact same thing. If you look, here's 2001 and 2002. Here's 2001 and 2002 again. But once again, what they did was they zoomed in on this gap right here. Really, they just took this and they blew it up. And you can tell that by looking down in the second graph. They have this right here. It jumps from 0 to 14. And they notate that with this notation. And that is something that is used. But it makes it look like a much bigger rise in snowfall between the 2 years just by changing the graph a little bit. If we take a look here at law school applications on the rise, if we look for Wisconsin and Marquette, it looks like, wow, there's these really big increases going on because they've zoomed in. Our graph, once again, it doesn't start at 0. It starts at 1,500, and it goes up to 3,000. And so they've zoomed in once again on the graph, and it looks like there's a lot more increase going on than there truly is. We can see the same thing on this one. They're trying to show that, wow, if Bush tax cuts expire, there's going to be a lot more taxes that adults are going to have to pay. But if you look at the numbers, here's 35%, here's 39.6%. It's really only going to go up by 4.6%, which isn't that much. And you can and they're trying to mislead us with this graph and make people be upset and kind of get worried. But once again, they zoomed in. Their graph doesn't start at 0, it starts at 34. So it would look drastically different if our axes actually started at 0. Here we can see that again with another graph. If you look, here's 81. Well, if that's where 81 is, well, then 91 is just going to be right above it. But really, it's way up here. They once again zoomed in, tried to make it look like it was a bigger deal than it truly is. So number one, The first thing you need to pay attention to with misleading graphs is that your graph starts at 0. Another thing to pay attention to, here we have a 3D graph. And a 3D graph, it's scaled. So if you think about it, okay, if you follow this line across, these two buildings are really the exact, if these were buildings, the orange one and the blue one would be the exact same height. So they're really the same percentages. And this yellow and the purple, they're pretty similar in height. And so they're able to mislead us by making it a 3D graph and make these 97 and 98 look a lot smaller than they actually are. So number 2, no 3D. Just stay away from that. Here we have some graphs where, okay, this one starts at 130 and this one goes up to 210. So it's got a lot more spread. It's zoomed in. Well, here this second graph is the exact same data, but it's condensed a lot more. And so it doesn't look like there's as big of an increase going on there. It's more of a curve rather than a point going on because the scale is a little better. But notice still both of these do not start at 0. We can tell that. And so here we have teacher job satisfaction over the years. Well, once again, our graph really isn't starting at 0. We've got 40% here, 59% here. So it looks like maybe teachers really are way more satisfied with their jobs in 2009 than they were in 1984, but really it's not all that different. So one thing to pay attention to too is the labels as you're graphing. Number 4, you should also pay attention to the scale of the graph. So if we look at this next one, pets, well, about 3.5 people have dogs. And if you look down here, well, 2 people have turtles, but 2 looks like a lot more than it does up here with the dogs because they're using bigger graphics. They're trying to mislead us. These cats are 4.5. And it looks like it's more than it is because the graphics are misleading. It's the same thing with this next one with French fries, hamburgers, and hot dogs. Well, if each French fry is 50 is 10, that means there's 50 French fries sold here. Each hamburger is 10, that means there's 40. Each hot dog is 10, that means there's 30. Well, hot dogs appears to be the biggest portion. However, if we're following the key that they gave us down here, hot dogs is actually the least. And so definitely the labels and the images can be very, very misleading. Here we have changing jobs, and each symbol represents 10% of all gainful workers. And so this is a little bit misleading as well. It's kind of going back and forth, and there's 4 different things that they're trying to show with all these different people, and it's very distracting and very ambiguous at times. Here on this one, they're trying to show that YouTube is getting a lot more views and a lot more videos uploaded than it used to. Well, if you look at the size of one of these, it's much bigger than these, and so it's really not that big of an increase from 2010 up to 2011. It's really only increasing by 13%, but it looks like it's increasing. It's doubling just from looking at the images because, well, they're percentages. They're using these little devices to show percentages, and the ones up in 2011 are a lot bigger, and so that's very misleading. Here, once again, we have that image problem where compact cars that are different by seniors, there's really 40. Mid-size, there's 30, and truck, there's 20, while truck, they all look like they're, truck, compact, and mid-size look like they're the same amount, but really they're not. Truck is really 20. It's really the least. Next, we can look at another one that says foods with the highest tryptophan content. And so they're trying to show you that tryptophan, I believe, is the chemical that makes you sleepy. And everybody always says after Thanksgiving, oh, I'm so tired, and it's because of the turkey that I ate. And so they're trying to get across that, hey, well, turkey really, you shouldn't really be that tired after eating turkey. But I don't know about you, but after Thanksgiving every year, I'm always tired because it's just so much food and so much work set up for it. But they're trying to be misleading with this once again, with their scale and with comparing all these different things. And so in pictographs, we need to make sure the objects are the same size, unlike that car one and the hamburger one. They're trying to be misleading with the size and make something appear to be more than it actually is. It's the same thing here. These trash cans look, the 1980 trash can looks way bigger than the 1960 trash can, but it's really only double it. It looks like it's maybe quadruple. And if they had maybe drawn the same trash can twice, then we could compare it a little bit better. But with the images, they're making the amount of trash in 1980 look way more than it truly is. Same thing here with Halloween candy collected. Michael's looks a lot bigger than Shayna's, but it's really only double what Shayna had. And so if we look at improper scaling, okay, here's one of those pictures like the last two where one is a lot smaller and then one's a scaled up version. If we want to show that in a better way, this would be, I believe, a little bit better way to show it and easier to compare. This is now showing us that, oh, well, A is this person and is this much, but B is triple that amount, and we're really getting that accurately from this pictograph. It's the same type of thing here with Starbucks and Wendy's and McDonald's and Pizza Hut. If we look at the Starbucks icon, it's really small, which makes you feel like they're really not producing that much sales, whereas this McDonald's icon, it's huge. If they had done just a regular bar graph, it would have been easier to compare this, and it would have been maybe would have been a lot more accurate in our perceptions. Same thing here with baseball and basketball games. Once again, for the ticket prices, if they had maybe done 2 little baseballs in there, it would have been easier. It would have been more accurate comparing, or 2 basketballs in there. It would have been more accurate to compare those. So one thing to get from those is don't replace the bars in a bar graph with pictures. Just keep it simple. Make a simple bar graph. It's a lot less work and a lot more accurate. And so I hope from this today that you have learned that, how a graph is presented. There can be some bias in that, and that we need to pay attention to how we're setting up our graphs and what we're using to do them. And so our essential outcome for the day was that you will be able to talk about and describe misleading graphs. I would like you now to write a summary of what you learned today and any questions that you have. This is the end of lesson 5 of chapter 2 of probability and statistics.